we have learned that electric field intensity due to an infinitely large thin plane sheet of charge is given by sigma by 2 epsilon naught, and so this is the plane sheet of charge. So this is the plane sheet of charge. If it is positively charged, then at one particular point this electric field will be in this direction, that is perpendicular to the plane and away from the plane. Here also same way, in this region perpendicular to the plane and away from the plane, if the sheet is positively charged, and the value is given by sigma by 2 epsilon naught. And remember, it does not depend on distance. You can see here there is no distance term in this expression. E is equal to sigma divided by 2 epsilon naught. And you can have only sign, because if this direction is taken as positive, this will be taken as negative. So we can say this as sigma by 2 epsilon naught I cap. This field will be given by sigma by 2 epsilon naught minus I cap, that minus will come here, minus sigma by 2 epsilon naught I cap. Likewise, and if it is negatively charged plate, if it is a negatively charged infinite plane sheet of charge, then electric field will be directed towards the sheet. Here also it will be directed towards, the sheet if it was negative charge density. For positive charge density, it will be directed away and perpendicular to the sheet, and for negative charge it will be perpendicular to the sheet, but it will be towards the sheet electric field. Magnitude remains the same, it will be sigma by 2 epsilon naught only, sigma by 2 epsilon naught magnitude, and this is in the positive direction and this will be in the negative direction. In the light of this, concept, let us find out the electric field intensity due to two parallel infinitely long thin plane sheets of charge. Instead of one, if we have two parallel infinitely long thin plane sheets, then what will be the electric field due to both? That we can find out. First case, there are two plane sheets, and one is having charge density sigma 1, the other is having charge density sigma 2, and sigma 1 is greater than sigma 2. So this is sigma 1. Another one is there, sigma 2. What happens? So we can have three regions we have. One is here, one is here, and one is here. This is infinite sheet, infinitely large. So these two sheets will separate the space into three regions. This is region 1, this is region 2, and this is region 3. And each sheet will exert its own field in these three regions. Now you see, take this particular point here, or in this region, electric field due to this first sheet will be in this direction because it is towards to this side, and this is positive charges. So sigma 1 is positive charge density. So field will be directed away from the sheet. Similarly for E2, you see this is the sheet and this is the point here. This is the point and this is the sheet. Therefore, at this particular point, electric field due to this second sheet will be directed away from that sheet. That's also in this direction. So E1 and E2 are in the same direction. And you can see here, in this region, you see E1, it is directed away from this first sheet. So it will be in this direction. You can see arrow mark. And what about E2? Here sheet is here and the point is to this side. Therefore electric field will be in this direction. You can see E1 and E2 are in the opposite directions. And in the third region, again the points are on the same side of both the sheets. Therefore electric fields are in the same direction. So region 1, region 2 and region 3, and electric field you will need to take the vector sum. In the first region it will be E1 plus E2 because both are in the same direction. So it will be sigma by 2 epsilon naught. It will be sigma 1 by 2 epsilon naught and sigma 2 by 2 epsilon naught E2. Here it will be sigma 1 by 2 epsilon naught, but this should be written as minus sigma 2 by 2 epsilon naught because E1 and E2 are in the opposite direction. Here it is sigma 1 by 2 epsilon naught. Here it will be sigma 2 by 2 epsilon naught. So here you have to write E is equal to E1 plus E2. Its magnitude is sigma 1 plus sigma 2 by 2 epsilon naught. But if you are considering as vector, it will be in this direction, and if this direction is taken as positive, our conventional direction, if it is taken as positive, then this will be having negative value. It will be in this direction only. Now talk about region 2. Sigma 1 by 2 epsilon naught, sigma 2 by 2 epsilon naught. So it will be E1 minus E2. So sigma 1 minus sigma 2 divided by 2 epsilon naught it will come. If you add these two, sigma 1 by 2 epsilon naught, sigma 2 by 2 epsilon naught, if you add it will be sigma 1 minus sigma 2. And again in the third case, E is equal to sigma 1 plus sigma 2 by 2 epsilon naught. As we have told, sigma 1 is greater than sigma 2. Sigma 1 is greater than sigma 2. If you are putting, say, E, if you are showing with vector notation, then this E will be minus of sigma 1 plus sigma 2 by 2 epsilon naught I cap. Say this direction is x direction, so this will be in the negative x direction, so it will be minus I cap. It should be there, and here it will be I cap only. E will be equal to sigma 1 minus sigma 2 by 2 epsilon naught I cap only, because we have taken sigma 1 is greater than sigma 2. So sigma 1 minus sigma 2 will be positive. So resultant field will be in this direction only. It is shown here in this direction only, in the I direction only. Similarly here, resultant field is in this direction, positive x direction. Therefore, E will be equal to sigma 1 plus sigma 2 by 2 epsilon naught I cap. I cap is the unit vector in the positive x direction. The negative x direction, it will be minus I cap. So this minus will come there. This is the case of two infinitely large parallel plane sheets of charge with sigma 1 greater than sigma 2. And what will happen if one is having positive charge density and other is having negative charge density? Let us see to that. Two sheets are there. They are infinitely large, parallel, very thin plane sheets of charge, but one is having positive charge density and the other is having negative charge density. So this will be the condition. For positive plane sheet of charge, electric field is away from it, electric field is directed away from it. So here it will be E1 will be in this direction, here E1 will be in this direction, here E1 will be in this direction, in this region 3. But for the negative plane sheet of charge, field will be directed towards it. So in this region, it will be directed towards it. So it will be in this direction. It will be in this direction as shown here. Here also, it will be towards this sheet. So it will be in this direction. But here in the region 3, it will be in this direction. That means in region 1, E1 and E2 are in opposite direction. Region 3 also E1 and E2 are in opposite direction. And in region 2, they are in the same direction. And remember, here also we are taking it as sigma 1 is greater than sigma 2. Then, resultant field, magnitude only I am talking, E is equal to E1 minus E2 because E1 and E2 are in opposite directions. The magnitude is sigma 1 minus sigma 2 by 2 epsilon naught. Here they are in the same direction, so you can add them. Sigma 1 plus sigma 2 by 2 epsilon naught. The third case also, it is similar to the first case because E1 and E2 are in opposite directions. So it will be sigma 1 minus sigma 2 by 2 epsilon naught. And one interesting case will come along with this, that is sigma 1 and sigma 2 are equal and opposite. That is, one is plus sigma and the other is minus sigma. It is of very useful practical importance, this one. So sigma 1 is having charge density sigma 1, other is having charge density minus sigma 2, but they are equal. Sigma 1 and sigma 2 are having the same magnitude, So we can show it like that: sigma 1 is equal to sigma 2 is equal to minus sigma. And as we know, electric field will be in the opposite direction in this region, because for positive sheet it will be away from the sheet, and for a negative it will be towards it, because this point is here and this sheet is here, negative sheet is here. Therefore electric field will be directed in this direction, towards it. But in the region 2, E1 and E2 are in the same direction, because it will be away from positive sheet, so in this direction. It will be towards the negative sheet, so again it is in this direction. And here again you see they are in the opposite direction, because this point is with respect to this positive sheet, so it will be away from, directed away from the positive sheet. But this point is with respect to this negative sheet, so it will be directed towards the negative sheet. So E1 and E2 are in the opposite directions. So we are having these equations here because you can see in region 1 we have told earlier it is sigma 1 minus sigma 2 by 2 epsilon naught. That was we got there. Sigma 1 minus sigma 2 by 2 epsilon naught, because here sigma 1 and sigma 2 are the same, magnitude will be the same. So one is plus sigma 1, so one is plus sigma and other is minus sigma. That's all, it will be getting cancelled. So they will be having the same magnitude. It will be sigma divided by 2 epsilon naught. This will be minus sigma divided by 2 epsilon naught. You have to add these two, so that it will become 0. Here also sigma by 2 epsilon naught. This will be minus sigma by 2 epsilon naught. Again it will be 0. And in the region between these two sheets, you can see it will be sigma by 2 epsilon naught and sigma by 2 epsilon naught. Both are in the same direction. So it will be getting added. Sigma plus sigma by 2 epsilon naught. So it will be 2 sigma by 2 epsilon naught. 2 sigma by 2 epsilon naught will be equal to sigma by epsilon naught. That means this sheet will divide the space into 3 regions: region 1, region 2 and region 3. Electric field exists only in the region between these sheets. Electric field exists only in the region between the sheets. On the other two sides it will be 0. So this principle is used to create an electric field in a desired region in space. If we want to have electric field only in a particular region, we can have a parallel sheet arrangement, or any arrangement leading to this kind of a result we can make use of. So that is why this point is very much important. Hope you have understood. Please go through this explanation once again, or as many number of times till you understand, and draw, visualize the direction of the electric fields and finding the resultant of those fields, and practice